Okay, so according to the previous page's examples, we have the logical plans for the queries already, right? And now we have the logical plan, which are usually not optimal. And for this logical plans, we can get by converting the SQL queries to the relational algebra, these kinds of logical trees or logical plans. In most of cases, they are not optimal, and they may have some shortcomings. So therefore, we need to further optimize them to achieve better plans instead. According to this section, we have two different kinds of approaches to do the optimizations. The first kind of approach is called the rule-based or the heuristics-based algorithms or methods to do the optimizations. And the second one is the cost-based methods for kinds of optimizations, right? And for the rule-based methods, we can apply some laws that can seem to result in cheaper plans or better plans. And we can have different kinds of rules to be introduced, or the laws to be introduced in this section, and which can be used for optimizing these logical plans. And we can also introduce some heuristics which can be used for further optimizing this kind of logical plans. We will mention some examples like push selection down, as well as sometimes push selection up and then down, which can be used for optimizing these kinds of logical plans. Another method we can use is a cost-based method. We can estimate the size as well as the cost of the intermediate results and then search the system for better plans or best plans. So normally this kind of method may require the estimation of the size of the plans, and for calculating the size, we normally need to use the parameters we introduced in the previous sections, denoting the size of the blocks as well as the number of tuples, as well as different values for some relation attributes, right? And you can go over the parameters again to be used in this section as well as for estimating the size as well as cost for the intermediate results. For the optimization methods, normally we have three components. The first part is the algebraic laws, which can be used for optimizing these kinds of logical plans, which will be normally used for the rule-based algorithm. And based on these laws as well as heuristics, this kind of metrics, right, we can use some algorithm for optimizing the logical plans. In other words, we need to have an optimization algorithm as well. In this section, we will mention that we will use the dynamic programming to help us to search for the better plans for the query executions. In other words, the optimization algorithm to be used for optimizing these plans will be based on the dynamic programming in this section. I hope you still remember the dynamic programming, right? This is covered in the algorithm courses. I think you have known before. You can go over this kind of materials on the dynamic programming, this kind of algorithm to be used in this section. Another component to be used is the cost estimator. So once we are using this cost-based algorithm or the methods, we may need to estimate the size of some intermediate results. In other words, we have to build a cost estimator to estimate the size as well as the cost for the intermediate results, which will be useful as well as necessary for designing better plans for the query inputs. Alright, so this will be the three main components to be focused on in this section, on both the algebraic logic, the optimization algorithm, as well as the cost estimator, which will be studied in section one by one.